All right, friends, last one, the crazy one. The square roots, the fifth roots, the eighth roots, all that algebra that I made you skip that I'll explain later through short videos for those of you who want to know. We saw with the difference quotient, hopefully, or at least you believe me that the answers are correct, that this is what happens. If m is the square root of x, its derivative is 1 over 2 root x. If p of x is the third root of x, its derivative ended up being 1 over 3x to the 2/3. Somehow, I'm saying it's this exact same pattern, which means we need to be thinking about this as x raised to a specific power, x raised to an exponent. And so here's where somewhere in your life someone taught you about the connection between nth roots and rational exponents. So I'm going to give you a moment to just kind of like jive with this whole idea of like when you take the derivative, the coefficient changes, and the new coefficient is the old coefficient times the power. And the power also changes, and it's whatever the previous power was decreased by 1. Pause the video, see if you can't make sense of what's happening here. It's the same rule, it's just that we're going to have some fractions happening. Pause your video now to think about it. And if you think you see it, you probably do not need to watch the rest of this video. And if you're still like, I'm not sure, Mr. Debsick, let me just pull one of these. Let's look at the grossest of them all, which I would say is this one. And the first thing I'd want to do, if asked to find the derivative, I certainly don't want to do all the math that's actually required when we apply the limit of the difference quotient. It is hideous math. It's not pleasant. It's good for your soul, I'll say that. But here we're going to want to think of this as x raised to a power, and we know that a fourth root is the same thing as x to the 1/4 power. And of course, we know there's like this little, if it's helpful to put a 1 in front of this, to think of what the coefficient is in the beginning, please do that. It's a great idea. And then to apply this rule of find the derivative, it's going to be power times coefficient is new coefficient. So in my head, I'm doing a 1/4 times a 1, which of course is 1/4. Ding, 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 ding. And then there's a new power on x, and that new power is going to be whatever I get when I subtract 1 from this. And I'm going to tell you guys a little secret about myself. It was doing this kind of math that made me finally feel comfortable subtracting and adding fractions. I mean, of course I knew how to do it when I was in high school, but if you asked me to do it, it always made my stomach hurt a little bit. And after doing this work a million times, I got really good at doing it in my head. And it just comes down to the idea that whatever this fraction's denominator is, in this case that denominator is 4, I'm going to think of this as not a 1, but as a 4 over a 4. My brain just starts to do it. So if you think of it that way, then of course that new coefficient 1/4 is still 1/4. And in my head, if I do 1/4 minus 4/4, I know that I'm just dealing with those numerators, 1 minus 4. 1 minus 4 is -3, and then that denominator just gets carried around. I don't think about it as much. And that, by the way, like if I ask you to find the derivative, that's a perfectly fine answer. It's just hard to evaluate if you get an actual number for x to plug in there, which is why it might be beneficial to then rewrite this as, this always kind of confuses kids, so I'll go a little slowly. This has a negative exponent on it, so it has to be thrown in the denominator. The 4 already is in the denominator, so they can just be in the denominator together, and that's why you get something like what we have over here. 1 over that 4 was already in there, and then it's x to the positive 3/4 power. And if I want to go even further, I might think about that as it's helpful sometimes to know that x to the 3/4 power is the same thing as the 4th root of whatever you are given and then cubing it. But that's more for evaluation purposes, and that's what we'll deal with as we move forward with this stuff. Right now, I'm just hoping you guys can see how this one rule for exponents, we've seen it play out. And again, I can't emphasize enough, no reason why this needs to be true. It just happens to be true. Isn't math a beautiful thing? I think it is. All right, guys. There's going to be a homework assignment. If it's not there by the time you get to the end of this video, it'll be there before the end of my first math analysis class. So it'll be there before 11 a.m. It'll be a really short assignment to see if you are understanding what the heck is happening here. Good luck. See you on Wednesday.